I have everything on one side of the inequality already, so now I just need to factor. If I factor my numerator, I get x minus 4 times x plus 3. Factoring my denominator, I get x plus 3 times x minus 2. I want this greater than 0. Okay, then I find my zeros of my numerator and denominator. I get x equals 4 from the x minus 4. I get x equals negative 3 from both the numerator and the denominator. And I get x equals 2 from the denominator. Now for each of these, I'm going to go ahead and indicate the multiplicity, and this is where it gets a little bit strange. I get my multiplicity of 1 from my 4, but the negative 3 showed up in 2 different places. So I need to add those together, and that tells me that this is, in a way, a multiplicity 2. And that x equals 2, that came from this, which has a multiplicity of 1. Okay, I need to now plot these on a number line. I have negative 3, 2, and 4. This breaks my number line into 4 sections. I need to label these negative 3, 2, and 4 as either 0 or undefined. Okay? At 4, I know it's equal to 0 because that came from the numerator. And at 2, I know it's undefined because that came from the denominator. The negative 3 came from both. And what we need to know there is that the denominator trumps. Okay? Because it's in the denominator, we know it's undefined there. We're not actually allowed to plug in negative 3. Now I need to find out what these different intervals are, whether they're positive or negative. We can plug any number we want from any of these intervals. 0 is a really easy number to plug in, and it's right here between negative 3 and 2. So if I plug 0 in to my numerator, I get a negative 12 over negative 6, which is positive 2. So that's positive on that interval. Now, as I move to the left across negative 3, that had a multiplicity of 2, which is even, which means it does not change. It's the same. As I move to the right across 2, that has an odd multiplicity, which means it changes. And from there across 4, 4 had a multiplicity of 1, which was odd, so it changes there. So from negative, it changes to positive. Now, when writing my solution, I want when this rational function is greater than 0. So that means I want it to be positive. So I see that I'm positive here from negative infinity, and I'm positive all the way up to negative 3, and then between negative 3 and 2. But right at negative 3, it's undefined, so I can't write something that includes negative 3. So I have to break at negative 3, not include it, and then do a union from negative 3 up to 2. At 2, it's also undefined, so I can't include that. And then I've got my last section that's positive there, starting from 4, and at 4 it's equal to 0, but I don't want it equal to 0, so I can't include that either. And then up to infinity. That's my solution to this rational inequality.